Hello, everyone. Thank you for attending today's webinar, Simply Secure, Leveraging the SIM to Create a Trusted IoT, presented by GSMA. I'm Monica Alvin, editor at Fierce Wireless Tech. A few technical notes before we get started. If you'd like to download the slide deck, please click the Resources List button at the bottom of your screen. The webcast is being streamed through your computer, so there's no dial-in number. For the best audio quality, please make sure your volume is up. You can find additional answers to some common technical issues located in the Help button at the bottom of your screen. This webinar is being recorded and will be available on demand within 24 hours after the event. We will follow the presentations with a Q&A session. Please submit your questions using the Q&A button on the left side of your screen. All right, let's get started. Ian, please go ahead.
Okay, thank you. So I'm Ian Smith from the GSMA. I'd like to welcome you to this latest webinar in a series of IoT-related webinars from the GSMA. Today we're going to be discussing how we can use the SIM to create trusted, secure IoT services. Okay, so we have an action-packed agenda for you today with 4 leading IoT security experts at our disposal. We're going to start with a quick introduction from myself to give a background to this webinar, followed by 4 short presentations from our experts. So just to run through our agenda, we've got Remy Crico, who's the chairman of SIM Alliance. We have Senthil Ramakrishnan from AT&T, Miguel Angel Ricio from Telefónica, and Antonio Delgado from Amazon Web Services. So after the presentations, we're going to have a Q&A session, so please submit your questions through the console as we go through the presentations. So let's get started. So just a quick introduction to the GSMA. We're a trade organization. We represent the mobile network operators plus several hundred associate members in the mobile technology business. You've probably heard of our events that we run. We run a big event called Mobile World Congress in Barcelona, also Mobile World Congresses in Shanghai and Los Angeles. Why are we here today? Well, a couple of years ago, the GSMA published the first version of our IoT security guidelines. These are a freely available, comprehensive resource to help anybody developing a connected thing, and explains how to address this sort of thorny subject of IoT security. It's an extensive resource that we've created. It's over 200 pages. It contains many detailed recommendations of how to mitigate the sort of principal attack that IoT services will be subjected to. And it's a resource that we keep regularly updated. So we first published a couple of years ago. It's been updated. I think we're at the 4th revision as of now. And as you can see, it's being well supported by other organizations in the industry. You can see Global Platform, GSA, IoT World Alliance, and SIM Alliance supporting this initiative. I'm not going to go into the resource in too much detail. You can more than welcome to freely download that and have a look at that yourself. But I want to focus in on one of the key recommendations in the guidelines, because that's what we're here to talk about today. I'm often asked the question, so what is the key security challenge that we need to address in IoT security, and how do we address, what do we recommend to address this challenge? It's a difficult question to answer. Of course, there are many challenges, but probably the most fundamental challenge we need to address is how we implement what we call a trusted computing base within low-cost, low-power, simple endpoint devices. This is obviously key to underpinning many IoT services. What do I mean by a trusted computing base? Well, this fundamentally is how do you secure device identity, the security credentials in the device, and the key security functions in the device. Effectively, these things are needed to underpin the overall security of the IoT service. For the mobile industry, this challenge is a bit like deja vu, because it's the same challenge that we had to address many years ago when we were developing the first digital mobile networks. And we needed to develop, as part of that design, a secure mobile phone. So way back then, we came up with a solution called the SIM. And this solution has secured mobile services ever since, and will continue to secure mobile services into the future. So we asked ourselves the question, can we leverage the SIM to secure IoT devices and services? And of course the answer is yes. And a number of GSMA members have been working on these solutions, and we recently published a case study called Leveraging the SIM to Secure IoT Services, which describes several of the activities that our members have undertaken. We're lucky today to have several people who are involved in this work here to present to you now. We'll go through their presentations in a few seconds. So firstly, we're going to hear from SIM Alliance, who are going to tell us more about the capability of the SIM and why the SIM is a trusted entity. We're then going to hear from AT&T and Telefónica and AWS about the solutions that they've been deploying specifically to help secure IoT services. So that's my very quick introduction. I'd like to hand over to Remy from SIM Alliance to talk about the capabilities of the SIM. A final reminder to please submit your questions as we go along. I'd just like to hand over to Remy.
Thanks, Jan. Hello, and thanks for joining this GSMA webinar. My name is Remy Cricot, and I am the chairman of the SIM Alliance. So let me put the slide on. Okay. I am glad to spend time with you today about how the eSIM can help in IoT security. So, SIM Alliance, we are a non-profit industry association composed of SIM vendors and technology partners. As you can see on the slide, so we represent 90% of market share in SIM and eSIM shipments worldwide, with a delivery of 5.6 billion of SIM and eSIM in 2017. Today, I would like to insist on how the eSIM can help to prevent hackers making clones of your IoT devices and attacking services, assets, people, and infrastructure. We can observe mainly two ways of attacking. First, physical attacks to one device, to spy it, to get secrets out of it, and to build clones that will be used to attack your services and perform DDoS attacks to infrastructures. Then the second one that we also need to consider is remote attacks from the cloud to thousands of devices at the same time. What is the status today? What are the findings, in fact? Most of the deployed IoT devices do not implement strong security to prevent those physical and remote attacks. Why? Because device makers and service providers are missing security expertise. This is improving day by day, we have to admit, but we still need to make some effort. And also because the users, so you and me, are also missing some education about the risk and how to prevent them. So how the SIM can help? First, we have to make sure about the device integrity. So this is the first attack we need to consider, and we also need to prevent cloning, device cloning. For this, the eSIM can play an important role because the eSIM will help to perform a secure boot of the device and then check your software integrity and during the boot, but also to check signatures of each downloaded programs in your IoT device when you want to load a new service or you just want to update the software. As a second step, the eSIM can also be used to protect the communication between your device and your cloud platform by signing, encrypting, and decrypting the data you are going to exchange between the two entities. So let's take a small example. We are going to focus on smart city, as you can see on the slide. So first, let's start with a fiction, hopefully. I invite you to read this book, which is called Blackout. So you can see the picture on the slide, which is going to explain you how a remote attack to non-protected devices can lead to a complete chaos. Then let's focus on more concrete examples now from the SIM Alliance members. First, we start with GND, from our member GND, which has developed a very powerful solution where the eSIM is managing certificates for the device and the service. So this is going to be explained later in this webinar by my colleagues. The second example is from IDEMIA, which is involved in the project to develop some services for connected parking, trash collection, and traffic lights in the city, in a big city. So I think this is quite easy to say that we all agree that if we just consider and if we could focus on traffic lights, we don't want a clone of the traffic light to be developed by the hackers, because this clone is going to send some fake information to the service platform in the city, and of course this is going to unsynchronize the traffic lights and drive to accidents. This is something we need to take seriously into consideration during the service design and not after, because this will be too late. I think this slide is the most important one to remember from this presentation. I guess you all know that the SIM and the eSIM is very useful to connect your devices to cellular networks in a flexible way. You are all using it in your smartphone, and this will be, of course, deployed in billions of IoT devices in the coming years. But I think we also need to understand that the eSIM is an open, secure, tiny computer which is able to keep secrets and execute some sensitive programs to protect your device and services. You can see on the slide there is a high-level architecture on the right side where the eSIM is having its own CPU to execute some programs, its own memory to store operating system, programs and keys and certificates, data, but also its own cryptographic processor and the communication module with your to communicate with your device. So let's take an example. Let's say that you want to protect the communication between your device and your service platform, which is in the cloud. For this, you are going to load a specific programs in the eSIM when the device will be already deployed on the field, so you can do it after, but you can also do it before if you want. And then this program will be executed in the SIM, and the device, your device, will be able to use it in order to protect the communication between your device and your cloud services. So then you can encrypt the communication so you can protect it, and you can of course sign as well your data to avoid man-in-the-middle attacks. Well, let's conclude. Of course, we can spend hours to discuss about cybersecurity, attacks, hackers, and the eSIM, and the role of the eSIM in IoT security. But I just wanted to give you, let's say, this overview. And to conclude, I think we need to remember that the eSIM, which is provided and deployed today by SIM Alliance members, is already in your IoT device to handle connectivity. You need the eSIM if you want to connect to cellular networks. So saying this, I mean, it's quite easy to leverage on it because it's already there, and then to perform some security service. Also, we have to consider that the SIM and the eSIM have never been hacked and cloned because they are running on highly secure chipset. eSIM is also done to keep secrets and certificates, but also to execute your sensitive operation, as I explained before. In fact, the sensitive operation you don't want to execute in your device because there is no security in your device. Then the eSIM, I mean, is using standardized APIs and commands. So they are interoperable. And this is very important for you because you want to use, let's say, all the possible eSIM you are going to find on the market. And then whatever the brand you are going to use, so the way to use it will be the same. If you need also to certify your device because you are managing some very critical data, you can, let's say, certify your eSIM by using some external labs that will do some penetration tests and so on. And finally, eSIM is not going to disturb so much your manufacturing and supply chain because it can be remotely administrated from the cloud and be personalized. You can load program to perform your security in your device, and you can also use this kind of cloud services also in order to detect some devices which have been cloned by sending some challenges, for example. Thank you very much. I hope this was interesting for you. Feel free to ask a question at the end of the webinar, and of course, feel free to contact SIM Alliance.
Okay, thanks, Remy. So we'll now move to our next speaker. Over to you, Senthil.
Thank you, Ian. Hey, thank you for joining the webinar. I'm just going to take a very short amount of time to talk about, how AT&T is working with G&D to take the EUICC and using it to solve one of IoT's biggest issues, which is device identity. So, about a couple of years ago, we'd gotten together with G&D and we, started looking at how we can solve some of the, higher priority IoT security issues. And the issue that kept coming up, and I think that, Remy talked about it in a lot of detail as well, was really around device identity, right? And as more and more IoT devices start being connected by over the cellular network, these devices have a SIM embedded in them. And we wanted to take that SIM and start using it to provide a device identity back into the IoT application that device is being used for. So, these SIMs today essentially are there to authenticate and be authorized to use some of the or most of the network resources, right? So that's the primary use case. So we said, how about we take this existing SIM, this existing security capabilities, all the security features that the SIM brings along to it, and extend the same thing out to the application layer, so that the SIM can now be used to authenticate and authorized to use resources at higher layers like the application layer. So that's essentially what we did. So we started off with a proof of concept with G&D, where we were able to store customer certificates on the SIM, and then allow the customer access to those certificates securely so that they could use it. And then quickly we understood that in addition to providing these certificates, we also have to have the ability to manage these certificates throughout the life cycle of that device and that application. So, post POC, we've been working with our good partners as G&D to extend that certificate management capabilities within the SIM by providing a front end that is tied into the customer's infrastructure, and also providing the back end that will use the SIM OTA platform to download and manage the certificates on the SIM. The solution itself is going to be agnostic to the back end. We could provide it with any cloud provider like AWS or Azure or IBM, any of the cloud providers out there, or it can also work with any enterprise hosted applications or data centers as well. So the solution really solves two main security issues for IoT. The first one being the IoT device identity, right? That certificate or key or credential for that device, the provisioning of it and the management of it throughout the life cycle of the solution. The second one is being able to securely provide a secure storage for those credentials. Today, most IoT devices store the certificate or the key or the credential on device, on flash, And as you guys know, there's a lot more attacks or side channel attacks that are a lot more accessible, a lot more vulnerable on the flash side. So we said, hey, how about we move away from the flash and move it to a much more secure location, and that ends up being the SIM. So from a solution capability, right from the provisioning of the certificate or key on the SIM, all the way to managing that, that's part of the solution. We pre-provision these SIMs with credentials and keys, depending on who the provider is, so that we can enable zero-touch onboarding. Right? We don't have to push or keep provisioning the device. Once you pop that SIM into your IoT device, it not only authenticates back into your network, but also back into your backend application. And then, of course, we should be able to provide access to those credentials on the SIM. Now, if it's a key, we should be able to provide, especially if it's a private key. We don't want to expose the full private key to the user. So, the ability to generate session-based keys, etc. Those are things that we are building into the solution as we move along. So this is sort of the overall flow of how the solution works. So, essentially, I've sort of marked the steps 1 through 5, and I'll walk through them. But essentially, to begin with, we need a certificate authority, right? That could be a certificate authority that AT&T and G&D bring together. It could be a certificate authority that the customer is bringing, but that is integrated back into G&D's platform during manufacturing. Right, so as these SIMs are manufactured, the credentials are pre-provisioned onto those SIMs specific to that customer, and then stored on the EUICC. So now, when a customer gets these SIMs, the network, of course, is provisioned, so they already have access, like data access. And now, using that data access, the device can then use the onboard credentials on the EUICC to authenticate back into their backend server. Now, that authentication can either sit at the customer side. It can be something that AT&T or G&D can provide, which can then, federate down to the application if that's necessary as well. So that's why you see that authentication service in the middle. The IoT devices themselves get API access or AT command access to the credentials that are stored on the SIM. This makes it very easy for the the developers to get access to the right set of credentials as well. Our vision or our roadmap going further down is that we have the ability to store multiple keys and manage multiple credentials on the SIM. Because as you guys know, some of these IoT verticals, the devices are a lot more complex, and they're not just running or talking to one or two backends, they're talking to multiple backends. And so the ability to support multiple credentials and keys on the SIM become critical. An example is, the connected car, right? There's multiple services running inside the car, telematics or telemetry data going back to the car OEM, maybe infotainment services going back to third parties. So the need for multiple credentials, keys on the SIM becomes a critical use case as well. The last part is really the management of these credentials, especially in mission critical IoT use cases. You need to be able to renew these certificates or revoke these certificates based on other security criteria and policy. So the provisioning is the pre-provisioning is possibly the simpler way, the simpler option to do things. But once the credentials are on the SIM, we are using the AT&T OTA platform to manage those certificates. So we have a front end that is tied into the OTA platform that customers can then log into. It can either be a portal, eventually API access for that as well. But they're able to, perform all the certificate management functions: renewal, revoke, delete. Any of those functions can be done, and that goes through the SIM OTA platform as well. So the provisioning of the SIMs, the zero-touch onboarding, the ability to securely manage your credentials on these devices, and that application authentication at the application layer, that solves a major part of the IoT security challenges that these customers are facing. Now, you couple this with other secure connectivity options that cellular brings into play, and then you can start looking at an end-to-end secure solution for IoT devices. So no matter where they are in the globe, what type of IoT device it is, we're sort of abstracting a lot of that security capability into the SIM, because as you guys are very familiar, the SIM is already performing a lot of these functions for the network layer. And so by extending it to the application layer, we're making the adoption of IoT faster and also a lot more secure. And that's the end of my slide, so I'll hand off to the next speaker.
Yeah, thank you, Senthil, for that overview. So we're now going to hand over to Miguel to give a presentation of the Telefónica solution. Over to you, Miguel.
Thanks, Senthil. Well, my name is Miguel Ángel Recio. I work for the IoT security unit as product manager. IoT security unit is a common initiative of two global units in Telefónica. One is the global IoT, and the other one is 11path, that is the global cyber security unit that is proposing solutions for IT classical products and solutions. Okay, my main task here is to lead the creation of new security services for specific IoT scenarios. One of them is precisely the one we are dealing with today. Okay. How we understand the end-to-end security in IoT here in Telefónica, I think it's a common view for all of us. It's well known that Telefónica try to provide an offering for end-to-end solutions and focusing in the value of the data. And like most major telcos, our objective is to play a pivotal role in the IoT value chain. Okay. In this slide, we show how at Telefónica we understand the security in IoT with an end-to-end vision. In this vision, there are three well-differentiated parts: the network security, the security in the service platforms and application, and the security in the devices. Applied to the service platforms and applications and part of network platforms, traditional IoT security products and services from our 11path portfolio can be used applying an IoT SIMs in combination with our classical 3GPP network secure capabilities. However, in IoT scenarios, new elements need a special focus. Those new elements, for sure, they are the devices. We impose IoT-specific security challenges like the scaling and the limitation of resources, or the remote operation that we already talking, or the long life cycles that might be addressed. Okay. Here in Telefónica, we would like to go beyond the IoT connectivity at all levels. Okay. Telefónica is providing the managed IoT connectivity services that span for public or private networks, 2G, 3G, LTE, narrowband IoT, with our platform that's called BASE. Okay. But we have made a strong investment in staff and processes to put in a position to face with complex projects. So we would like to cover end-to-end solutions for vertical markets and provided, for instance, security solutions or analytics that can apply to an end-to-end view for the whole services. With that in mind, last year in Mobile World Congress, we presented a prototype solution together with Amazon Web Services, where Telefónica was demonstrating how the cellular-enabled energy meters connected to the Amazon Web Services in the cloud, and how those devices can securely receive digital certificates over there using the energy meters SIM cards. This solution enables the secure authentication between the energy meter and the Amazon cloud. And the SIM is guaranteeing secure transmission, the storage, and updating of these IoT credentials. Okay, so we are trying to solve the customer pain, how to set up those device credentials during the bootstrap at IoT scale. Okay, and to avoid this manual provisioning or in secure configurations, we all know that in many cases still the default configuration is maintained in many IoT devices. And the solution is based on user, as my colleague Gentil has mentioned as well, and user the cellular identity with the SIM and standard over the air procedures. The value proposition, so in one sentence could be, as stated in the slide, to simplify the provisioning of the IoT device credential, leveraging on the mobile network operator core assets to streamline the device onboarding in the IoT cloud, okay? And preserve that trust in the IoT devices and those applications. The benefits for the customer, first one is just to have a trust anchor in the SIM card and the Telefónica network to verify the identity and the integrity of the IoT devices. The second one is to provide a service where the customer can control the whole life cycle management for those credentials. Okay, they can issue credentials in real time to make a renew or revoke to ensure that the connected devices are exactly what they claim to be. Okay? And the third one is the cost reductions associated to mitigate some risks from error-prone tasks or avoiding firmware customization to manage those credentials in the device instead of having them in the SIM card. And the fourth one, but the last but not least, is a straightforward integration within public clouds like Amazon, or it could be Azure or Google, because we provide all the tools to make that enrollment just during the bootstrap processing. Okay. But okay, we are thinking for this year, and we have already started last year, to industrialize the solution. Okay, and we are talking with customers and manufacturers of devices and seeing vendors. Okay, but we see 4 key factors that we would like to talk about today. The first one is we need to have a customer focus, and we think that to get on board key customers from specific industries areas like utilities or connected car, we think that, for instance, the cellular V2X will be very, very full of this type of solution, and to get impact. Okay, this type of solution needs to get impact in the market. We have seen many times using solutions using PKIs, but still there's not, let's say, big deployments for IoT. And then we need to grow the ecosystem to boost that traction. Okay, so I think that this is a good forum for doing that, talking with SIM vendors or with the IoT platforms or device manufacturers as well. And the solution proposed must be cost effective. We cannot make something very complex and costly for the end customer, because in the IoT world, the customers does not have a very good control of the end-to-end solution. So if you impose another complexity in one of the elements that are less known, that are the devices, I think it will be an error from us, from our side. And then we really believe that to achieve this, we believe in value of standards to give to the market. Standardized solution to encourage the customers and the industry players, because at the end, we know that today it's with one operator or another, or using some type of cloud, but if the customer doesn't feel free to decide, to make their own decisions and choose the operators of the cloud that they need in one moment, I think that the solution will not fail. And that could be achieved only with standards and interoperability of all the solutions. So that's all from my side. We'll be pleased to answer your questions at the end of the webinar. I will hand over to Antonio from Amazon Web Services. Thank you.
Okay, thank you. So yes, over to Antonio, please.
Hi, good afternoon. Hello, everyone. My name is Antonio Delgado. I am a solution architect in Amazon Web Services. Thank you for giving us this opportunity to explain AWS perspective in IoT and in security, and how we can leverage the SIM for trusted IoT. In AWS, we say security is job zero. Security is and will be always our top priority, from physical data center security to application level security. We have built all our services to satisfy the security requirements of the most demanding organizations. And a proof of that is that over 50 global compliance certifications that we have. Customers and partners can leverage the experience and best practices to build an application with the most demanding security requirements. And this, the same, applies to AWS IoT services, which is the topic for today. Because from AWS IoT, we are able to manage the authorization and provisioning of devices at any scale, no matter thousands or millions of devices. We are also able to do this with the highest level of security. As a matter of example, we enforce TLS 1.2 for the encryption of the communication between devices and the cloud, and we also require certificates for mutual authentication. In this way, we can be sure that the cloud is talking with the right thing and the thing is talking with the right cloud endpoint. Besides that, we have the capability to define fine-grained policies per group, per device, and even per action. So you are always in control of what your things can do or what your things cannot do. But from AWS IoT, we can provide additional security features. Thanks to AWS IoT Defender, as a matter of example, you can define what is the valid behavior of a device. And if the device suddenly becomes very chatty, maybe it has a vulnerability or similar, and it starts to send bigger payloads because a DDoS attack, then you will be automatically notified and you can take the appropriate action. Like, for example, disabling deactivating the thing, or even revoking the certificate on the device. But an end-to-end IoT solution includes many parts, sensors, and end devices, maybe gateways, and of course network connectivity, an IoT platform, IoT application, an integrator to put all the pieces in one single place. Therefore, IoT security is a matter of all the components in the IoT end-to-end. There are many characteristics that are unique about Amazon, but there is one that really summarizes how we think and operate all of our businesses. And it is customer obsession, which is across the company and everything that we do. And our customers, using this, they can secure their IoT solutions in an end-to-end scope. For these reasons, we have done reference implementation with chipset providers to use secure elements for trusted IoT. And for the same reason, we are happy that we have collaborated with Telefónica when they offered to partner with us to build a more secure and automated IoT for our joint customers. Telefónica and us know that when it comes to scale, to secure the delivering of certificates and store them securely in the end devices, it's a challenge for many organizations. It is not complicated to install certificates in a few devices, You all know that. But when you are in the bigger scale, it's a different thing. So when it comes to production and devices are on the field, you have to find a way to deliver unique certificates, fully automated, and that has to work at any scale, not just your prototyping phases. Telefónica and AWS developed a joint solution using standards. This is super important, and my previous colleague also mentioned it, that we want to rely on standards. We take advantage of the just-in-time registration method from AWS, so you don't have to pre-register the SIM, and over-the-air capabilities of Telefónica. In that way, we leverage Telefónica's network security. Only allowed SIMs will be activated and go live, and will get an unique certificate from AWS IoT. The delivery of the unique certificates will be done in a secure way via provisioning SMS using Telefónica's OTA platform. And finally, the unique certificate will be stored in the secure memory of the SIM. This simplifies credential provisioning into devices and avoids firmware customization, leveraging the SIM as a simple and secure way to connect your things. And customers can seamlessly connect to AWS IoT and start sending and analyzing data right away. So at AWS IoT, our mission is to make sure that you can know the state of everything, of all your devices, and that you can take decisions based on that data, so you can truly solve your business problems. With this promise in mind and following customers' feedback, we have created an extensive IoT portfolio that we can structure in device software that you can install in your hardware, choice to connect in an easy but secure way up to the cloud, control services that you can use to control, manage, secure your devices at any scale, and finally, data services to extract value from this IoT data that I mentioned before. And this is just, I'm finishing here, and I would like to summarize that this is our complete portfolio of AWS IoT services that enable customers and partners to create business value from IoT. We don't have time to go over all of them, so let me highlight only a few of them. In device software, we provide IoT device SDKs in almost any programming language to handle the security we have mentioned before, TLS 1.2, mutual edge certificates, etc. We also provide a software called AWS Greengrass that can be installed on your gateway to take action on your IoT data locally, even without connectivity to the cloud. In control services, AWS IoT Core is more than IoT broker in the cloud, and it is probably the most mature IoT offering in the cloud. It enables you to have millions of devices with trillions of measures in a pay-as-you-go basis. And this opens up the whole AWS service portfolio, from analytics to machine learning to virtual reality for your IoT application. In data services, let me highlight AWS IoT Analytics. IoT data has been frequently meeting significant gaps, corrupted measures, and sometimes false readings. Also, IoT data is often only meaningful in the context of other data from external sources. So IoT Analytics is a fully managed analytics service that enables you to filter, enrich, and define your own custom processing logic to easily analyze your IoT data. I hope this short introduction clarifies what's the perspective of AWS in IoT and how we can collaborate with customers and partners to achieve a secure IoT end-to-end. And with this, I hand it over to Ian. Thank you.
Thanks, Antonio. Thank you for your presentation. Thanks for all the presentations. So we'll now move to a Q&A session. I've had a lot of questions submitted. We'll do our best to get through as many as we can. If we don't get to your question, we'll respond to you via email. So just a common question actually has been asked by several people, is about whether these solutions are proprietary. Obviously, the scenario here is if you're looking to deploy a global IoT service, you may wish to obviously have the same solution deployed across many different regions, potentially across many different telcos. What aspects of this, the solutions that have been demonstrated are proprietary, which are standards-based, and so forth. So I'll perhaps go around the table on this one because I think most of the speakers will probably have a view on this. We'll start with Senthil and then work our way through. So Senthil, do you have a view on this?
Hey, sorry, Ian, you cut out a little bit there, so if you wouldn't mind repeating the question, sir.
I'm sorry. Okay, so a question asked by several people is about whether these solutions are proprietary. Obviously, for IoT, many services are globally deployed across many different regions. There's a question here about, well, how would I go about deploying a SIM-based solution across multiple regions? Now, do I have to implement proprietary solutions in each region, or can I look towards a standard solution?
Sure. I'll start off with just a product pitch, and then I'll go into the standard side of things as well. So the solution is part of AT&T's global SIM platform that we've worked out with G&D. So this solution is not limited to any geographic location. You combine this with subscription management, and you're able to provide this capability across the globe, right? Whether it's roaming or re-credential to a local MNO, we're still able to provide that using AT&T's global SIM. The second piece, standardization in a lot of cases is really good, and I think Ian has initiated some of this work now, where he's trying to get the leaders in the industry together to maybe look at how we can standardize some of these solutions, not only across carriers but across SIM providers as well. So I think that's coming sometime in the future.
Thanks, Senthil. Miguel, would you like to add?
Yes. For instance, something that, the use that we are doing, for instance, to supply the certificate from Amazon or from any other platform, they are the ones that they provide. We are not doing anything special, so in that sense, we can say that anyone could do it. Okay. I think that some work must be done in the standardization and how we store in a common way those credentials in the SIM card, for instance, and the provisioning of those credentials into the, let's say, into our SIM management platform, just to make them afterwards the standard over the procedures. Okay. But we are not, let's say, using nothing different that the industry nowadays provides, but some of those specific procedures we think that should be considered to standardize in order to be adopted for anyone. Okay.
Okay, thanks, Miguel. Antonio, do you have a view on this? Obviously, Amazon, you're looking at providing a global product, global service. Do you think you can deploy these kind of solutions in a uniform way with each of the telcos?
Yeah, absolutely. The joint solution that we have done with Telefónica is not a proprietary solution at all. We're using the same API to provision devices and register certificates that any other AWS customer can use. So at the end of the day, we are just using standard protocols like SMS, which is a simple standard for the SIMs, and it's the standard method to use it. So in this approach, we fully agree with Telefónica to just rely on the standard, so any other company, any other telco will be able to integrate with us without any issue.
Okay, so there's your answer to the question on whether these solutions are potentially global solutions. I think we are heading down that path, and the GSMA will look to drive a global solution to address this particular issue. So moving on to our next question, and this one I'll focus towards Remy, because we have the question here about whether the SIM is only for cellular devices and whether there's a SIM solution that could be deployed in a non-cellular context. Remy, do you have a view whether the SIM can be applied in a non-cellular environment?
Yes. Today we are focusing on the eSIM because we consider cellular networks, but yes, we can also use the eSIM in non-cellular devices and networks. At the end, the eSIM is an embedded secure element. Let's say globally, we can call it like this, where the network connectivity is one of the applications of this secure element. So if we don't need cellular connectivity, we can still use the eSIM or the embedded secure elements in non-cellular devices in order to perform some sensitive operations. So the answer is yes.
Okay. Yeah. No, thank you, Remy. I think that's a clear answer. Let's go into I've got some specific questions for each of the speakers. So, specific question for AT&T, so for Senthil. So the question here is that how does AT&T generate the device identity, and how is that linked to the actual physical device?
So, either it depends on the customer, right? So we can either have the customer, we can be a sub-CA for the customer, we can bring our own CA, we can sign the certificates, but we also have a provisioning service that ties the SIM to that that SIM to that specific credential, and that is our provisioning service then registers that with the backend application. If we take AWS, for example, whether that's the AWS IoT gateway or whether it's the customer's own instance running inside AWS, the provisioning service is able to tie that specific credential to that SIM and provide that back into the backend application.
Okay, thank you, Senthil. Specific question for Telefónica, so for Miguel. It says, I think in one of your slides, that you certify also the identity of the service provider in your framework platform. How do you do that?
Okay, I don't know if we understood well the question, but okay. First, we establish a secure connection between the IoT platform and our connectivity platform. Okay, what we call a credential manager, that is the element in the network that manage those credentials. But then what we do is just recognize certificates from those IoT platforms that are using recognized certification authorities. So it's just to follow the trust chain in those certification authorities. Okay. In this case, we are using those that are provided directly from Amazon Web Services that uses a certified authority. So it's just a question of trust in this trust chain, okay, so to say. I don't know if we answered the question. And just to keep that trust chain with using those trust anchor that it's the SIM. So at the end, it's just to keep the trust chain between the element, the device, and the platform that is using a certified authority.
Okay, thank you, Miguel. So moving on, question for Amazon Web Services, so for Antonio. So question here, how do you ensure that the certificate is used by the right device?
Okay, yeah, we do that thanks to the device IoT AWS Device Defender. With Device Defender, we can establish expected behavior and desired configuration. And if anything changes or deviates from this, we can raise an alarm, and we then can take appropriate action. Of course, to avoid that the certificates end in a fake device or wrong device, we partner with connectivity providers like Telefónica and with hardware manufacturers just to secure the whole certificate delivery chain is the right one.
I would like to add, Antonio, that first we make authentication of that element, that device within the network, within the SIM. We authenticate that certificate. It's managed by the proper device that is already in our network, and we have provided an IP and the connectivity to them before it goes to your platform. So there is a double, let's say, double factor of authentication.
Thank you.
Okay, thank you. Okay, so rattling through these. The next question, so there's a question here about how does this topic relate to the EUICC solution from the GSMA? Maybe one for Remy, actually. So maybe there's some confusion here about some of the terminology we're using here. We've talked about embedded SIM, SIM, EUICC. How do these all relate to each other?
Yes, okay, Jan. So the SIM card is only having one connectivity profile, which is managed by only one operator. The eSIM is able to store several connectivity profiles, so several mobile network operators' connectivity profiles in the eSIM. And so if I come back to what I was explaining before, when I was mentioning, when I was, let's say, comparing the eSIM as a tiny secure computer, so then we can see that for example, the remote SIM provisioning architecture, which is defined by the GSMA in order to handle flexible connectivity, is just one application that you can run on this tiny computer, which is the eSIM. But you can add, of course, more applications, and these applications can be added by device makers and IoT service providers in order to handle security, store certificates, and manage, let's say, various sensitive operations.
Okay, thank you, Remy. I think we've probably got time for one more question. I could say if I didn't get around to answering your question, we can respond through email. So last question, it's one specifically focused at Amazon. So we have the certificate in the SIM. How is the certificate read and used by the device? Is there kind of an SDK or some sort of API on the device? Can you elaborate on how the device actually then utilizes these credentials?
Okay, sure. So we are using, I think that the right answer will be a mixed answer between me and Miguel, because we share the role there, but answering the question is using secure methods. So the device, in this case, a script in the device is running on the secure memory, and this script is accessing the certificate and using it to communicate to AWS IoT. I don't know, Miguel, if you want to add any additional detail on the process, but basically the process is this one. It's a secure script running inside the SIM, which has access to the certificate, and using them, it's realizing or creating the connections to our platform.
Yeah. Nowadays we are using let's say a proprietary API, and that's what we are trying to promote, this standardization of the API to securely access those devices, and in the same way for all type of devices. Okay, because nowadays this is the key point that we think that it must be standardized. Okay, because something now proprietary that they have some dependencies of the element that we have behind the SIM. For that demo we use Gemalto, but in other cases could be another manufacturer. And that's why we are proposing here to standardize an API to access to those elements, those credentials and certification in the SIM. Okay.
Okay, thank you, Antonio. Thank you, Miguel. I think that's the last question we have time for. So I think we need to wrap up now. So I'd like to thank all of the presenters who've presented today. Thank you for sharing your views. I'd like to thank all of you who have tuned into this webinar today. Like I say, if we didn't have a chance to cover your question, we'll get through to you via email. So thank you for your time today, everybody. I'd like to hand back now to our moderator to close the webinar.
Yes, thank you. Thanks for attending this Fierce Markets webinar and submitting all your questions. I'd like to thank our speakers and GSMA for presenting today's webinar. This webinar has been recorded. You will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.